Alright, so today we're going to start talking about rational expressions. So we're just going to be recalling the words polynomial, coefficient, degree, monomial, binomial, trinomial, standard form, like terms, factoring completely, and other words that we need to be familiar with are known as special products. So special products just involve the words like sum and difference, sum meaning that addition is involved. Alright, and then difference, you guys guessed it or you guys remembered that difference means that subtraction is involved. Alright, next one we've got is square of a sum. I'm just going to zoom in slightly because as you can see I write kind of big on here. So I'm going to try to fix that so I actually have enough room. So square of a sum is just when I've got something like a plus b quantity squared, and then I've got technically a plus b times another quantity of a plus b, because that's all that square means. Something times itself. That something happens to be in the parentheses this time around, which is going to yield an a squared plus an a times b, which is just ab, plus a b times a, which is ba, or I can just rewrite it as ab again, because multiplication is commutative, which means that I can change the order. 3 times 5 and 5 times 3 both equal the same thing, plus b squared, because b times b gives me b squared. Combining my like terms, I should see that I get a squared plus 2ab plus b squared. Alright, that sum of squares follows that pattern every single time, so it's kind of helpful to not have to go through both of these steps. I can just go from here to here. Alright, just like square of a difference. Alright, I've got something that looks like a minus b squared is equal to a minus b times another quantity of a minus b, which is going to be equal to a squared, now minus ab, now minus another ab or ba, now plus b squared. Combine your like terms, you should get a squared minus 2ab plus b squared. And like that, we're done. Alright, so those ones are the ones that we've seen. Cube of a sum, I didn't give you guys enough room for, so I'm just gonna skip to the end result. So, cube of a sum. Alright, so cube of a sum, I'm gonna change it to look a little bit differently. Cube of a sum is actually going to look something like a cubed plus b cubed, and that's it, versus a sum of a cube would look something like a plus b quantity cubed, which I think you guys can figure that out just by doing this part multiplied by another one of a minus b's. So let me show you something different, which is that cube of the sum. I'm going to go ahead and show you guys how this factors, which is going to be a minus b times the quantity of a squared plus ab plus b squared. Alright, and then we're going to look at a cube of a difference. So again, cube of a difference is that a cubed minus b cubed instead of the quantity of a minus b, all of that quantity cubed. So that's going to factor into being now a plus b times the quantity of a squared minus a b plus b squared. So a couple things I want you guys to note is that the sign does not match in that first set of parentheses in comparison to our first bit that we started off with, compared to the sign on the second set of parentheses always will match that original sign that we had when we were trying to factor this. Okay? Other than that, everything matches. And those will help you out quite a bit. Alright, so these are going to be useful to recognize throughout this course and the next. But first, let's look at something that we hopefully know, which is combining like terms with addition or subtraction. And we have to remember that they have to have the exact same variables with the exact same exponents. If our two quantities with no exponents are on the outside of the plus, in between that set of parentheses, you can basically ignore the parentheses and just add like terms. And if you have two quantities with no exponents on the outside of with a negative sign between the two sets of parentheses, you should distribute that negative first. I see way too many sign errors and all that kind of fun stuff. So please distribute that negative and then add your like terms together as you would. So problem 1, just trying to find the sum and the difference of these polynomials. So on problem A, I see that there's a plus sign, meaning that there's a sum involved. Since there's a plus sign, I can basically drop the parentheses and just add my like. See that I've got a 2x cubed and an x cubed, so I can add those together, giving me just a 3x cubed. I see then that I've got a negative 3x squared and no other x squared, so I just drag that down. Alright, and then finally I've got a 4x, a 2x, and a negative 5x, so positive 4x plus 2 should give me 6x, minus 5x should give me just 1x. And then I've got negative 1 plus 3. So I've got to add those together, giving me just 2. Alright, next one. I've got a difference going on, which means that I need to distribute this negative over that second set of parentheses. That negative affects everything that follows it. So I've got to distribute it over every single term, which is basically just going to change my signs. I do highly recommend rewriting your problem after you distribute it out, even though we can probably do that step in our head. Half the time we forget it though. So please just let me see that you can rewrite it out. Alright, and from here, now we just add our like terms like we just did. I only see one x cubed term. So I had that negative sign here, so please make sure it's out in front. That's the biggest issue I see. Next, I'm looking for like terms. I'm looking for x squared because I want my exponents to be in descending order, meaning they go from biggest to smallest. So I get plus 3x squared. I see my negative 3x. I see my positive x, so I should get negative 2x. And then finally, I have negative 4 minus 2, which should yield a negative 6. Cool, cool. Alright. Multiplying polynomials is just a little different. Hopefully we've heard of the term FOIL. I dislike it because it only applies when you have a binomial times a binomial. But I know that you guys have heard of it. So it gets the idea across, which is just distribution more than once is all that's happening if I see sets of parentheses right next to each other. Alright, so I've got 3x times 4x going on first, because I have to distribute that 3x, which should yield 12x squared. And then I have 3x times negative 5, which should yield a negative 15x. And then I have 2 times 4x, which should give me positive 8x. And then I've got positive 2 times negative 5, which should give me negative 10. Add your like terms in the middle, and you are done. That should yield 12x squared minus 7x minus 10. And you're done. Alright, next one. I got to distribute quite a bit. There's a reason I left a lot of room. This will be the last problem in this video. I've got x squared times x squared. Multiply by keeping your base. Add your exponents, so I get x to the fourth. X squared times 4x. I should get plus 4x cubed. X squared times 5 should give me positive 5x squared. Next piece, I'm gonna take 4x times 4x times x squared, which should give me a negative 4x cubed. And then I'm going to take my 4x times my 4x, so I should get negative 16x squared. Negative 4x times 5 should yield a negative 20x. Alright, and then finally, take your 3 times all of that mess, so you get positive 3x squared. And then you get 12x. And then you get plus 15. Let me go back, check all my signs. And then we'll add these all up. Alright, so I'm just going to add these all up. I do line them up if I can help it, just so I can just add straight down. Personally, I like adding straight down better. So the only x to the 4th term I have is that one. Adding my x cubed, I get plus 0x cubed. Adding these straight down, I'd get negative 8x squared. Adding these straight down, I'd get positive, negative, 8x plus 15. And then I'm done. I'll see you guys in the next video. We'll finish these up.